Thank you, Mark. Ed with ALS Tribology, and tribology actually is the study of friction, wear, and lubrication, just for your information. The company, we're a global company, and actually we have 7 locations in the United States and 2 in Canada. And globally, I think we have, I think it's about, what? 18, yeah. So, but I've been with the company for 20 years, and we do the fuel testing not only for Prime Power, but we also do their oil analysis and their coolant analysis, and they're a wonderful customer. We greatly appreciate your business. Thank you very much. And we're here, I'm here in Atlanta. The lab is actually located off of Spaghetti Junction, not too far away from here. But let's go ahead and get started here. This is the objective, the agenda, which you all have on your sheet. What are some of the objectives of this? It meets performance standards, whether it's within specification, either ASTM D975 or some biodiesel, whether it's within spec for number 1 diesel fuel, number 2 diesel fuel. Monitor fuel cleanliness. Is it clean and dry? Is there any waters, any dirt? Fuel degradation products. Identify contaminants, possibly the source. You can have maybe a lot of tank scale or something like that. We can test the fuel to see if it's rust, possibly. Monitor the effects of long-term storage, how well your fuel is aging and whether you need to treat it. Investigate operability issues, just basically looking at the quality of the fuel, whether it's good within spec, and failure analysis. If you ever have like an injector failure or a fuel pump failure, and say an engine's under warranty or something like that, they may want to look at your fuel and look at your fuel reports and testing. I know a long time ago, back when I was in the Navy, part of my job was refueling helicopters, and if they ever had a helicopter go down, the very first thing they looked at was the fuel. So, and where they fueled last and how clean that fuel that came out of that tank. So, okay, why test your fuel? They say oil is the lifeblood of the engine. Well, fuel is the food that feeds the engine to keep it running. So you want to have it nice and clean and fresh. So, of course, you're testing your fuel. You want to see what kind of contamination you may have in that fuel. You could be getting, clogged filters or something. You could have too much water. You could have microbial contamination, solid contamination, deterioration. When you get fresh, clean fuel coming in, you look at it, it's nice and golden color. What happens to fuel when it gets older, when it gets old? What color does it turn? It gets brown, right? What happens is that's the deterioration going on with the fuel. Air, when it comes into contact with fuel, oxidizes the fuel. And that darkening color of the fuel as it ages is due to that oxidation process. And what happens is in that oxidation process, you're basically forming resinous gums and varnish-type material in the fuel, okay? So you want to test for that. And then, of course, quality. You want to look at your CETANE, calculate the CETANE index. Is your flash point good? Is your distillation good? Is it still within spec for number 2 diesel? Okay. So, and here's just some slide of some fuel-related symptoms, of course. If you have too high of an ash content in your fuel, you could start forming engine deposits, clogged filters from too much dirt contamination, damaged fuel pumps, say your lubricity isn't good, or too much asphaltenes in the fuel. Clogged fuel injectors, obviously, get a lot of junk in the fuel. Water, definitely. And of course, bacterial growth would all be fuel-related symptoms of engine problems, okay? Contamination, this is a slide just talking about if you have 1 million gallons of fuel in a year, and you had 0.05% of that fuel was contamination, what would it be? Well, 0.05 by volume would either be like 500 gallons of water, 250 pounds of dirt, and so on. And you'd be going through 7,200 filters, capacity of 4 ounces in each. And of course, while you test your fuel, you want to avoid, unnecessary repairs and downtime due to fuel-related issues. And again, more than 85% of fuel system problems are related to contamination, either dirt or water. And it's just some sources. Obviously, the oil, when it comes out of the ground, when it's drilled, pumped up, it's got to go through various steps before it gets to either the retail, your distributor, or how they deliver it. So, of course, it's just some sources. You drill it out of the ground, it goes to the refinery, goes into storage, then from the storage, then it's transferred to the terminal, transferred to a truck, it could be transferred through a pipeline. Before it gets to its final destination, of course, all those processes and along the way, you can pick up contaminants. Some common contaminants, obviously there's water, probably number one. Inorganic debris, which would be like tank scale, rust, that's in the tank. If you've got an old tank, dirt, which is sand, dust. And then, of course, you got organic debris, sludge, which was the oxidation byproducts, the resinous gums that are formed in fuel as it gets older. It forms a sludge. Wax, of course, wax is in all fuel. Asphaltenes. Quick question, asphaltenes, any of the generators, standby generators, do they have any of the high pressure rail fuel systems? No? Okay. It's generated a lot of, well, most like your over-the-road trucks, your common rail fuel systems. And then, of course, you got bacterial contamination, and a little statement there saying more than 50% of the tank contamination is generally organic. Okay. And some of the effects of water contamination in injector life, depending on how much water you have in the fuel and the damage it'll do, the erosion. It's came from Cummins, and it shows the amount of water, and this is in parts per million. 10,000 parts per million is actually 1% water, okay? 5,000 is a 0.5%, 1,000 is 0.1% water, and as you can see, obviously, the more water, the less life, the less water, the more life you'll get out of your injectors, okay? It's definitely important for maintaining your engines and with fuel quality. Filter plugging, obviously, there's a lot of external contamination, internal contamination, contamination from tanks. Again, talking about the fuel age, those resinous gums will conglomerate on the filter. Talking about causing, particulates, the gum, the discoloration, and that's from high temperatures. Low temperatures in the south, I don't think is that relevant, but of course, it does get cold, definitely. And of course, when you get low temperatures, you've got filter problems due to wax buildup, okay? Some slides just showing some injector wear issues due to dirt and water, and how the constant, you get a lot of erosion wear on the injector surfaces just due to dirty fuel and the high pressures that the fuel is going in through the injectors. And if you've got dirt or particulate contamination in your fuel, you're just going to be basically bombarding your surfaces with hard particulates, and it's just going to be eroding and causing erosion wear. And some more, again, injector wear, just showing more nozzle seat. And all these causes are, of course, just due to dirty fuel or dirt, particulate contamination that's in the fuel, okay? And just going to some classification and properties of fuel. Number 1, number 2, number 4, diesel fuel is all considered light or middle distillate fuels. And there's the ASTM, which is the American Society of Testing Materials, their D975 standard specification for diesel fuel oils. When we are doing the testing and we are evaluating the fuel, that's the standard that we use for that up to fuel. The D975 standard specifications applies to those fuels, okay? Yes.
Does this mean that we've always been told to avoid biodiesel anyway?
I would assume in your situation, yeah, because biodiesel itself, being that it's biodegradable, it will become acidic. It does not age well, and not having quick turnover, I assume, in your tanks. Sometimes I don't know how old your fuel can be. Yeah, what happens is biodiesel gets rancid. It gets old. This is like, you know, rotten food in the refrigerator kind of thing.
Is there a standard for biodiesel
Yes.
that everybody is supposed to adhere to?
There are, well, for biodiesel standards, there's the one standard for B100, actual pure biodiesel, okay? Coming out of wherever it's being made or being processed, it has to meet this specific ASTM specification for B100 pure biodiesel. And then there's a second standard that's coming up in this next slide. That's for the blends, B6 through B20. So there's.
Can you tell when you sample it if there's biodiesel in it?
Sure. There is a test that we can do looking at the FAME, what they call fatty acid methyl esters in fuel, which will tell you the bio content in the fuel. Whether you got B1, B2, B11, B20, whatever.
So if I'm supposed to have plain diesel and I've got biodiesel in it.
Yeah.
Now, are manufacturers allowed to do that without telling you?
No. No. You know, B2 is a legitimate blend. They do, I know at going to ultra low sulfur diesel fuel, there was a boatload of lubricity issues at the beginning at one point in time. And at the rail, or at the rack, I'm sorry, where they were dispensing fuel, I know that sometimes they do use, not very much, but they do use a very little bit of biodiesel that they add to the fuel, straight fuel, to improve lubricity of the ultra low sulfur. Okay, maybe maybe 0.5% at the most. So, nothing to really affect the quality of the fuel, but just to improve the lubricity. So, okay, yeah, biodiesel does not age well at all. So, I don't think it would be applicable in you know, your situation. We really don't turn the fuel over that much. Okay. And then again, here we were just talking about, yeah, this is the standard that we go by. If you've got B6 through B20, okay, and this is basically just your number 1 or your number 2 diesel fuel that's being blended, okay, with B100. Okay, there's an actual specification for that, and which are stated as BXX, where the XX is either, like I said, 2, 10, 11, or 20. So I think most engine manufacturers allow up to B5. Going back, I just saw a truck, was a Ford truck the other day in the parking lot out of a Cracker Barrel that had a big B20 on the side of it. So actually, that's what, I guess they're coming out with more of that, but that's of course on the road stuff. So. How biodiesel made? It's just a trans-esterification process where you take methanol and you've got either your oil or you got your animal fat or your vegetable oil, whatever. You mix it all together, you let it sit for a while, and you get a separation phase. 3 different phases of separation. Okay, so and then basically the FAME, or the fatty acid methyl ester, the FAMEs, that's the biodiesel content. That's what goes into the making of the biodiesel. Of course, your glycerin goes one way to make soap, and then your methanol, they reuse it to make more biodiesel. So, okay. Not too, so we're gonna go to some of the testing of what we do, why we do it, and how they're performed. Okay, CETANE number. Basically, is the ignition quality of the fuel. Here's a quick description. The time period between the start of the injection and the actual ignition of the fuel. Fuel quality or ignition quality. The higher the number, the shorter the delay interval, better the fuel. Okay. Low number can result in some of these things. You know, poor performance, cold starting, excessive smoking, rough running, ping, idling, knocking. The specification for using either number 1 or number 2 diesel is you want a CETANE number of 40 minimum. Okay. On your reports. We do a calculated I can't state really. Yes, it will. Due to the aging of the fuel, it can.
It floats around a little bit.
Yeah, you will.
Not
And
too much, but it does.
right, it shouldn't.
Well,
Hmm.
when we do a calculated CETANE index in the laboratory, and the API gravity of the distillation is used to do that calculation, and if there's any fluctuation in the distillation or the API, whether it's 0.1 difference, it will change that CETANE index.
Hmm. So
it can fluctuate. It's not going to be
exactly the same number.
exactly the same every single time.
Can I affect it by fuel polishing, scrubbing, or anything else?
Should not. No.
Not that I know of.
Mm-mm.
So a movement of a small amount is normal.
It is normal.
Because it's based on the process.
Right.
But anything more than 10% should be suspect?
Should be.
Yeah, that's.
I would assume so. Yeah.
Okay.
So as long as your API and your distillation are remaining the same. Now, you could have added different fuel to it.
That will
You
change
know,
too.
that will change it too. If you top off with fresh fuel, that may have an effect on it a little bit
Yeah, I mean,
as
I have
well.
a margin of about 300 to 400 gallons.
Hmm.
We keep we need a certain amount of runtime in the tank,
Right.
and we keep that in the tank, and I go between my maximum and that, and that's about 400 gallons.
Okay.
So, yeah, I have my fuel tested every time I add fuel.
Sure. Which is exactly. So as long as you're above 40, you're fine.
Okay.
So. No, thanks for the interjection. That's the actual CETANE number. They use its actual research engine that they use to perform a CETANE number at the lab level. We don't do this, of course, because this is a very timely and expensive test. But it can be done. We can farm that out if you'd like. What we do is a calculated CETANE index, and it's based off of the distillation numbers and the API gravity to calculate. It's a 4-point variable calculation that we do off of 3 points on the distillation and the API gravity to come up with what they call the calculated CETANE index. And of course, it's the same on the specification for number 1 and number 2 diesel. You want to see on your report 40 minimum, okay? Viscosity, of course, is important for the flow of fuel going through. You don't want it too high, you don't want it too low. Correct viscosity allows the fuel to atomize and lubricate properly. And so they've got the specifications in below. For number 1, which is a lighter grade fuel, so you're going to have a little bit lighter viscosity grade, 1.3 to 2.4, because it's a lighter distillate, thinner fuel. Where your number 2, it's a heavier, slightly heavier distillate, and you got 1.9 to 4.1, which is important for your lubrication on your fuel pumps and also your injectors. Okay. Distillation, this is how we can tell, the distillation test, this is how we can tell whether a fuel is a number 1, whether it's in specification for either being a number 1 diesel fuel or a number 2 diesel fuel. It's also really good for detecting if you've got any gasoline contamination in your fuel. It's also a very good test to perform if you've got any suspect engine oil in your fuel. Okay. You look at the recovery, basically taking 100 milliliters of fuel, you're heating it up, and you've got in a flask, and you're basically distilling it, cooling it off, and you've got a recovery cylinder. So you're heating it, taking it from one flask to a recovery cylinder, and what we're measuring is the temperature at the recovery at like 10% recovery, 50% recovery, 90% recovery, and the recovery cylinder at what temperature those levels are filled at. So number 1 diesel fuel, you're going to have a lower recovery, 90% recovery at 540 degrees, okay, which is the maximum specification for number 1. Number 2, because it's a heavier distillate fuel, your maximum is 640. And that we look at those numbers, especially at the 90% recovery temperature, to determine is it fuel number 1 or is it number 2, okay? Also, we look at the higher numbers to tell if it's possibly engine oil contamination. We see a lot of times, a lot of like number 2, people for some reason may add used engine oil to their fuel tank, and we can tell that because that maximum temperature on the 90% recovery is a lot higher. Say it's like in 700 or so, because it's got engine oil mixed in there, okay? All right. Ash content basically is, can form piston deposits. It's just soluble metallic soaps. Anything that's in the fuel from the process, like could be maybe some calcium or magnesium, those types. You want ash, and the reason why you want a very low number like 0.01 maximum is, of course, with those soluble metallic soaps, you can form excessive engine deposits. Okay, so you want it to be very low. Carbon residue measures the coking tendency. Again, it's kind of the same thing, but again, the potential of engine deposits as well. And the carbon residue, 0.15 max for number 1, 0.35 max for number 2. Okay. And then sulfur. Sulfur is a big test that we've been doing lately, especially with the implementation of S15 or sulfur. There's 3 grades of like number 2 diesel fuel. They call it S15, S500, and S5000. What that means is that it's just the sulfur content of the fuel. If you have a number 2 S15, okay, that means that fuel is an ultra low sulfur diesel fuel. It's got less than 1,500 parts per million of sulfur in the fuel. Low sulfur, which would be S500, meaning that it's got in between 15 and 500 ppm of sulfur. So that would be classified as a number 2 S500 diesel fuel. Anything above 500 ppm, they would classify that as an S5000. Okay, which should be between 5,000 and 500, which is the parts per million of sulfur that's in the diesel fuel. Okay. I think it was by 2014, everything's going to be ultra low sulfur. So, last point. This is basically a test to determine, if you have any light distillate contamination. It's 125 degrees minimum for number 2 diesel fuel, and it's 100 degrees minimum for number 1. It's an excellent test. Obviously, to determine if you've got any contamination in the tank, maybe through solvents or gasoline or something like that. This is a great test to determine not only that contamination, but the quality of the fuel as well, okay? And whether you're within spec, all right? KARL Fischer test, the latest ASTM regulation or specification, I'm sorry, not regulation, specification for number 2 and number 1 diesel fuel is 200 parts per million maximum, okay? And that's not the free water that's at the bottom of the tank or anything like that. That's the actual water content that's in the fuel, okay? Fuel will contain some dissolved water, some entrained water. It's natural. It's absorbed through the air. You always will have some minor trace amount of water, but it's very, very low amounts. Typically, you'll see it varies between like about 10 to 100 ppm, which is fine. But you don't want anything more than 200 parts per million of water in the actual fuel itself, okay? And that's just a picture of the machine in the lab that does that test. Okay, fuel cleanliness, the level of particulate contamination. Okay, we actually run a test. It's a membrane filter patch test in the laboratory. It's a 0.45 micron rated filter patch that we filter the fuel through it. We weigh the filter patch before running the fuel through it. We run a certain amount of fuel through that filter patch, then we weigh it again, okay? And that gives us our weight, okay? And we report that in milligrams per liter. Industry standard, it's not an ASTM standard. They're working on it. Maybe have one come out, but an industry standard for your particulate contamination that's in the fuel is 10 milligrams per liter maximum, okay? So anything more than that, your fuel's too dirty, and we go back once again to having possibly injector problems, filter plugging, and erosion on some injector surfaces, okay? Fuel cleanliness, microbial growth, bacteria, fungus, anaerobic, aerobic, microbial contamination loves fuel. You can have an anaerobic microbial contamination with no water. There are certain microbes and bugs that will live without air, oxygen, okay, without water. So it's very important. It's probably one of the main contaminants that we see a lot in the lab is microbial contamination. Especially if you've got water in the tank, you got to be very careful. You more than likely will have some form of microbial contamination if you have water in your tank. Okay. And it stinks and it clogs filters and it's not a good thing. It's slimy. Another test we do is copper strip corrosion. Basically, it's just going to tell you how corrosive, if corrosive potential on any copper or brass or bronze components within the fuel system itself. Okay, and there's just a specification 3B and 3B for number 1, for number 2, and basically when we run the test, we heat the fuel. We put an actual copper bar in a little flask of fuel. We heat it for a certain amount of time, pull that copper strip out after the test is done, and we compare it to this ASTM corrosion chart, and we give it a rating. Okay, so API gravity, measure the fuel density, which you can go into specific gravity, you can convert, you can figure out how much your fuel weighs, basically how dense your fuel is. Okay, for number 1 diesel specification, because it's lighter, it's 43 max. For number 2, diesel specification, it's 39, your API gravity. Typically, mostly like for number 2, though, you see the API gravity is anywhere between, I'd say about 30 to 35. It's typical, okay? And of course, generally it's with energy content, if it's used, we use the API for the calculated CETANE index, plus also if you want to calculate BTU content, it's also another variable with that. And here's this API versus specific gravity, which is the density of the fuel, and then you can calculate the weight of your fuel, if need be. So, see how heavy your fuel is, okay? Lubricity, this is a test, obviously you want your fuel to be able to, not wear on your fuel pumps, because of course your fuel is being subjected to extremely high pressures, okay? And you want it to be, you got metal surfaces that are coming in contact, you want your fuel to lubricate those injector parts, those fuel pump parts. And so lubricity is important. There is a specification for that, how much lubricity is in the fuel. If you got a lot of scarring, a lot of problems, you may have a lubricity issue with your fuel, okay? Especially if you're going through fuel pumps or injectors, you're getting a lot of failures. It's a 520 micron. I'll get to the test here in just a second. Especially,
That's not a routine test.
No, it's not a routine test, but it's something that we could have done if you're having injector issues or fuel pump issues with coming up with failures. You can have your fuel tested for lubricity, and if it's below specification, then that could be where your problem is, okay? And of course, with the reduced sulfur and fuel, which before, lubricity used to not really be a problem because the sulfur in the fuel itself was actually providing the lubricity in the fuel. Now they, of course, because they're removing all the sulfur out of the fuel, they're having to put in a lot of additives in the fuel to improve the lubricity, okay? And this is just the test stand that they do is they take a little round steel ball and they put it on this test stand, and basically they just they score it, and they put the fuel in a little cup, and for a certain amount of time, and they measure the wear scar diameter, and if it's above 520, then it fails. Okay. Acid number, this is the test for acidic constituents, age of fuel, the oxidation process of fuel we were talking about earlier, the aging, fuel turns darker. The oxidation itself is a weak form of a carboxylate acid, okay, which will become acidic, especially if you've got biodiesel, but of course that's really not applicable in your situation. But this is an excellent test also for determining age of fuel. If it gets really, really dark, you can see if it's very acidic, then you know you might want to treat it or replace it or blend it to do something to reduce the acidic content of the fuel, okay. The specification, number 2, 0.15, same for number 1, okay? And there's biodiesel. We had the question earlier, how do we measure? It's an IR, an infrared test that we do. Basically, the fuel itself has like a spectral fingerprint, and we run through a machine, and we're looking for a little peak, a faint, what they call the fatty acid methyl ester peak in this spectrum to determine the amount of biodiesel, okay? Long-term storage, of course, you got the clean fuel on the left, you got the aged fuel on the right, okay? So I would take, this is probably one of the most important tests for standby power generation systems is, you know, how well is your fuel aging, right? And do you need to treat it or not?
How old is, what's the difference in time on this?
You know, I have no idea.
Is that a year, 10 years? Or?
It could be. Yeah. So I would say, well, it's so dark on the side, they probably cooked it in the lab to take that picture, but it probably is 10 years, yeah. All right. There's 2 methods that we do for the fuel stability, the accelerated stability, the aging of the fuel. And the test results, there's four results on the report that you'll see. You'll see an initial color, a final color, and then a rating, a numerical rating, whether it's percent reflectance or it's from the DuPont F2161 chart. And then it'll say pass or fail. So you'll probably just look at the report, look at accelerated stability, which is the name of the test, and you look and see whether it's pass or fail. Depending on if we're doing the DuPont F2161, it's a numeric scale. Anything 7 or lower is a pass, okay? Anything higher than 7, I believe the scale goes all the way up to maybe, I think it's 21, actually. But the higher the number, the darker, the more aged the fuel. Also, we do the percent reflectance rating, which is done given a percentage. Anything above 80% is pass. Anything below 80% is fail, okay? The lower the percentage, the darker the fuel color, the more aged your fuel probably is, okay? So, and in the lab, what they do is they take a certain amount of fuel, and how they get the initial color, the color they call the ASTM D1500 color scale. It's a color scale. It's a numeric color scale between 0.5 and 8.0. Okay, 0.5 being clear like water, 8.0 being as dark as coffee. Okay, so when you look at your report and you see the initial color, that you're probably going to see a lower number on the scale. Okay, 0.5, 1, 2. The final color is the color of the fuel after the artificial aging process that we do in the laboratory. Okay, so you're always going to see a difference between your initial and your final color. Okay, and what the lab does, they use, I think it's 100 mil of fuel in a test tube, basically, and they stick the test tube in a heating apparatus, and they cook the fuel at 350 degrees for 90 minutes, which is supposed to simulate fuel aging over a 1-year period, okay? So that's how that test is done. So then we just look at the color before, the color after, we take the color after, and that's what we're looking at as far as when we do our ratings, so, okay? Low temperature affects the fuel. Well, I don't know if that's too much of an issue here. Maybe in the wintertime a little bit, definitely. Just mostly you're talking about wax. All fuel has wax. Especially ultra-low sulfur diesel fuel, it has more wax, okay? Although they're supposed to, when they refine the fuel, remove a lot of that wax out of it. But of course, wax contributes to filter plugging, and you get a lot of other issues going on with that. So, does anybody ever treat their tanks for cold storage? Do you do? Okay. So, when you treat a tank, basically, you're not removing wax. What the additive, the cold flow additive, all it's doing is it's basically manipulating that wax molecule to make it into a certain shape, so it's gives it a better ability to pass through and flow through filters, okay? So, this is just a cold flow test that we do. It's the cloud point, okay? what we do is we chill the fuel down and we look at the temperature. When you look at it, when it goes from being a clear sample, all of a sudden it's now cloudy. What's forming that cloudiness in the fuel is the wax molecule. It's the wax in that fuel. So that's called the cloud point. When you look at your report, it says cloud point. You know that's the temperature at which your wax crystals are starting to form. They're starting to conglomerate together. Pour point, as you can see, it's at the temperature where the fuel is just not going to flow anymore. You got the guys holding the cylinder there horizontally, and you can see it's not going anywhere. So that's the temperature where it's just not going to pour. It's not going to go anywhere. Okay. Another cold flow test would be the CFPP, or else otherwise known as cold filter plug point. And it's the temperature at which a certain amount of fuel will no longer flow through a 45 micron mesh screen in 60 seconds under vacuum. So basically it's when to expect you're going to have filter plugging problems. All right, some of the testing. Now we're going to go into proper fuel sampling techniques. 5? Okay, very good. You want a good representative sample, okay? That's the most important thing. Anybody in here actually take the fuel samples out of the tank? Yeah? Okay.
That's what I pay these guys.
All right, well, when they take a good representative sample, there's two things really what you want to look at when you're taking fuel samples. You want to look, and it really depends on what you want to know. If you want to know how clean your fuel is, draw a sample out of the bottom, okay? Bottom of the tank, that's where all your water, that's where all your particulate, that's all where your junk is going to be at, okay? If you want fuel quality, if you're just looking for the fuel quality of the sample, or of the fuel, I'm sorry, draw your sample out of the middle of the tank, okay? Because if you want fuel quality and you're drawing your sample out of the bottom of the tank, you're going to get nothing but junk, okay? Make sure all your sample containers and everything is clean. You label it properly. And of course, it's good for the lab to know whether you got number 1 or number 2 diesel fuel. We'll be able to tell once we do the testing, but if you're not sure, it's good for us to know.
When I pick up the phone and order, I just tell them, bring me over some off-road diesel. That's what I get.
There you go, and that's what you get. Is it red?
So yeah, it's red.
There you go, that's how you know. So,
It's,
dyed.
okay,
Yeah.
I mean, I know the dye. Is that number 1?
Well, if you tested it, you would be able to tell whether you're getting number 1 or number 2. We could tell you that based on the distillation and the flash point.
Is that something I can specify when I order? And if I can, what should I order?
I would say, depending on your application, you're going to get, okay, with number 2, okay, diesel fuel, you're going to get better combustion. You're going to get more power out of number 2, okay? So, whether number 1, number 2, that would be up to you in your application, and
Size of the generator.
yeah. So what they require, what the engine requires. So. Yeah, good clean fuel is what it requires. Yeah. Remember, fuel is a food that feeds the engine and keeps it going. So, and here's just there's different sampling devices that we offer that you can use. Where you can take the bacon bomb is that cylindrical thing right there. You can take a sample out of the middle of the tank or the bottom of the tank with it. There's sample pumps, there's tubes, and all kinds of other stuff. Supplies and equipment that you can use to draw a sample with. Again, some sampling guidelines. If you want cleanliness, see how clean your fuel is, draw it from the bottom. If you want fuel quality, draw it from the middle, okay? And here's just a typical test report. Like I said, we use either ASTM D975 as the specifications. When you get your fuel report, you're going to see the test, the method, what it is, the result, okay? And what we use the D975 specifications. So we're on the report, we're going to tell you whether it passes or fails. Is it within spec or is it out of spec? Very easy to read. Anybody can obtain the D975 specification or the what was the other one? D74. I got so many ASTM methods going through my head. What was the other one? Or the, oh.
67, no.
Yeah. So anyway, you can go to astm.org and you can actually download a copy of the specifications if you like to, either the D975 or the 7467. Yes.
Two questions. First of all, can you put on there what the allowable limit is, so it comes up on the report?
I don't know if that's a licensing thing with ASTM or not.
So I don't have to pull out a ASTM manual and go through every one of those. I don't know if I'm on the edge, I'm in the middle,
Right.
I'm on the low side. I have no idea of knowing that. And without putting that on the report, I can't get it.
Yeah.
Yep, that's the first part.
Right.
The area that we fall into is that if it's not defined as being a number 1 or number 2, we don't know which limits to put up for display. However, if it was defined, is it something we could do? Yes, because we keep the limits within our database, so that's easily obtainable to the diagnostician.
Tell me you're gonna find out whether it's number 1 or number 2.
We can actually see that in the,
And that's fine, what you find. If you put it up as number 1 and it's supposed to be number 2, well, I'll know the difference.
Right.
yeah,
But
but
the
see,
problem is I have no way of knowing when I see it, when I look at the report,
yeah, I see
what I
your
get.
point. I see your point. There's we could display, if it's tested as being a number 1, then at the time that we're doing the sample entry, we're actually defining what it is and what it should be lined up against. If it comes in as just being as a diesel fuel and not telling us if it's a number 1 or number 2, then it goes back to sample entry and having to change it. So it's based on what, it's like a garbage in, garbage out. The more information we put in, the better the output. But when we get into the diagnostics part, I should know how to say that word, we're using a chart within our database to review that data. Now the ASTM method that Ed keeps referring to is a real simple 1-page diagram that basically lays out each one of the diesel fuels.
I understand.
Yeah.
So, but we can't, I understand what you're saying, that if we could put those limits on there, yeah.
Now, they used to take a bottom sample and a center sample.
Right.
before. They're not doing that anymore. Is there a reason for that?
Don't know. No, like I said, as far as their sampling procedure, I have no idea.
They used to take a small bottom sample.
See what the, right, now, exactly, that goes back to the sampling procedures. Yeah, for tanks, you should be doing 2. One for the bottom to see your fuel cleanliness, and then one for the middle to see your fuel quality.
Now I only see them doing 1. Last question. Why does it take you so long to process my sample?
About how long is it, like a couple weeks or 5 weeks?
5 weeks.
I've seen it take up to 5 weeks. I have my sample cut, my fuel tested quarterly.
Okay.
More often if I get another piece. And it takes anywhere from a minimum of 3 to
Okay.
5 weeks to come back.
Some of that could be transit time.
No.
No, okay.
I'm a mile and a half from your location.
Oh, okay, okay. So you can drop it off. That's fine.
Coming back here.
Right, well,
Specify, you're dropping them off at the Atlanta lab?
I can.
I
If they
send them,
speed it up.
I know, but I send them to Cleveland process right now.
Beautiful.
I am
Yeah.
changing the testing capability at the Atlanta lab, so it's bringing in more fuel testing capabilities, which would speed up that transit time.
I can get my oil analysis in a
And the
week.
coolant is
I
done
can
in
get my
Atlanta.
coolant analysis in a week. I get my diesel analysis, which I have done 4 times as often, and it takes anywhere from 3 to 5 weeks.
I'll talk to Cleveland about that, but it should only be 72 hours from when they receive it.
how do you receive your report though, too? I mean, that's another thing. Do you get it online? Do you get it?
I figured that.
Yeah, so,
You know, you want to look at it, make sure it's okay.
yeah.
I can look at that. I'll look at that.
But some of the testing is,
Yes, thank you very much.
I've spoken to Richard about this issue.
okay, yeah. But some of the testing itself, like microbial contamination, that's
That takes 3
that's 3-day test, right, so.
But my concern is.
But I mean, in the 5 weeks thing,
My
yeah, that's
concern is
a little
having
it's long.
the range put on this. I mean, it's almost a gotta have it.
Well,
On
like I
the
said,
report.
yeah,
The
I mean,
website right now has.
You tell me pass or fail. I want to know how I got pass or fail.
Okay, the website right now, right this minute, has the ability to display limits for you, online. Whether it's on the PDF report is something that's been an internal discussion that we've had, just because we're talking about lubricants as well. I mean, fuels kind of are black and white, it's not, you know, additive sensitive, but what we're testing. It's the same thing with coolants, although coolants are different based on whether that's DLC or conventional.
We can carry this on later.
Yeah, absolutely.
At lunch. I'll bend
Wow.
your ear.
So any other questions regarding fuel? Anything else? The testing, what, good, bad? Anything? Yes, sir.
We have a test where we're drawing samples from the bottom of the tank, 4 inches from the bottom. Is that common or
Yeah.
normal?
Usually, like, if you're using like a bacon bomb, something like that, to sample your test, usually you drop it, you hit it, and then you bring it up just a few inches. It's common practice, yeah.
These guys have a bar that they put on the bottom. When they put it down, it's going to keep it about the bar off the bottom.
Right. Yeah.
It's a good practice.
That's good practice. Anything else? Question? No? All right. Thank you very much.